Since recorded data from the late 1800s, the Earth's global temperatures has steadily risen. Now, why is the late 1800s significant? Well, if you learn from your other classes, that was the start of the Industrial Revolution. And since then, our recordable data from that time has shown that the global temperatures has risen and is continued to rise. Now, typically, the global radiation budget, you're going to have 100% incoming solar radiation from the sun or visible light. Uh, Half of it, just about half, is going to be absorbed by the land and the world's oceans, and then the other approximate half is going to be either absorbed in the atmosphere or reflected back into space. Now, some of it, or the portion that gets absorbed by the land, it gets re-radiated back up into towards the atmosphere, which warms the planet. So the Earth emits or gives off energy in the form of infrared energy. And the majority of infrared energy is released back into the atmosphere or into space. Okay, but in order to keep the planet warm, okay, we need certain gases that help absorb this infrared energy, right, to keep our planet warm, of course. Now, things to look out for, just remember, visible light is going to have a shorter wavelength. Okay, so sunlight coming from the sun, insolation, incoming solar radiation is going to have a shorter wavelength. It gets absorbed and then gets re-radiated back up into the atmosphere in longer wavelengths, right? And those longer wavelengths are infrared wavelength or infrared energy or heat energy. Now, as I mentioned just previously, gases absorb infrared energy in the atmosphere, warming it slowly. So it keeps the planet warm. We need greenhouse gases to keep the planet warm, otherwise, the planet would be way too cold. This effect or this process is like a greenhouse effect. And you see in this image here, when you have a greenhouse, you have incoming solar radiation, right? It gets absorbed by from within the greenhouse, and then the glass protects the energy, the heat energy, but doesn't allow it to escape the greenhouse, thus keeping the greenhouse warm, right? Now, in terms of Earth, okay, the greenhouse gases that we should be familiar with uh, is water vapor, H2O, carbon dioxide, CO2, methane, CH4, nitrous oxide, N2O, ozone, O3, and chlorofluorocarbons, also known as CFCs. Now, we should know, for example, carbon dioxide is a natural greenhouse gas and the biggest human supplied contributor to the greenhouse effect, about 80%. It's a heavy colorless gas. Carbon dioxide, main gas we exhale during breathing. It dissolves in water to form carbonic acid and is formed in animal respiration and comes from the decay or combustion of plant and animal matter. Carbon dioxide is also used to carbonate drinks and absorbed from the air by plants in photosynthesis. Now, we do know the amount of carbon dioxide is about 40% higher than it was back in the 1800s. And you can get this further information from your review book. In terms of nitrogen oxides, it's a colorless gas known as nitrous oxide, is an atmospheric pollutant produced by combustion, which traps heat much more efficiently than carbon dioxide. There are several ways nitrogen and oxygen can team up in the atmosphere, including nitrogen dioxide, nitric oxide, and nitrous oxide. Since nitrogen oxides are stable gases and do not break down quickly, they build up in the atmosphere in greater concentrations. In the sky, nitrogen oxide creates a yellowish brown haze called smog. Now, methane, you hear uh, often about methane. Okay, methane is a big part of natural gas. and is found in the Earth's crust. Underwater decaying plants create methane known as marsh or swamp gas. One of the best known sources of methane in rural populations is that which comes from the digestive tracts of farm animals. Millions of cows, with their complicated digestive systems, release large amounts of methane to the atmosphere. Methane is a colorless, odorless, flammable hydrocarbon released by the breakdown of organic matter and carbonized carbonization of coal. A byproduct of the production, transportation, and the use of natural gas, it is the second biggest contributor, about 60% in 60% in 2014, to global greenhouse effect after carbon dioxide. Right? And of course, you have carbon dioxide. And carbon dioxide, carbon is essential to life. We need carbon. It's a organic element, right? We do have natural amounts of carbon dioxide into the atmosphere, but when you have way too much, okay, we can see, for example, the Keeling curve. So this curve, or this was data collected by atmospheric scientist Charles Keeling, and he was collecting CO2 data from Mauna Loa in Hawaii since 1958. And you can notice from 1958 all the way to present day, the amount of CO2 has continued to increase in parts per million, right? So steadily increasing to this day. Now you're going to have seasonal variation. This is why you have an increase through around April, around springtime, and then a decrease during the summertime. This has to do with seasonal changes. So what do we know? We know if we take data back 800,000 years ago, that there seems to be a correlation between the amount of CO2 into the atmosphere and global temperatures. When global when CO2 decreases in the atmosphere, global temperatures decreases. When CO2 concentration increases in the atmosphere, global temperatures also increases. Now, we as humans or anthropogenic source, we produce a lot of the greenhouse gases. For example, carbon dioxide. 65%, about 65% comes from fossil fuels and industrial processes. Then the other carbon dioxide from forestry and other land use. Then around 16% methane, then to a small amount nitrous oxides and your CFCs, chlorofluorocarbons. Okay. Now the largest contributor in the world of carbon dioxide into the atmosphere is China. Coming in second is the United States. Then you have the European Union, India, and so on and so forth. Now, what is the effects of a warming planet due to the greenhouse effect and burning of fossil fuels? One, you have melting of glaciers and ice caps. We know that glaciers all around the world are dwindling down. And also, we know the decrease in the ice caps. From that, as a result, you have sea level rise. So places or cities along the coast have a threat, will face a threat of sea level rise. The warming oceans, when you have warmer oceans, you have less oxygen, thus leading to loss of biodiversity in our oceans. You have a loss of habitat, which you can circle back to melting of ice caps. Polar bears need glacial ice to hunt, to feed. Without the glacial ice, more than likely, they'll have trouble adapting and they will eventually die out or lead to extinction. Population migration. We know places around the world, island nations, so places that are inhibited, where folks inhabit an island, the water level is rising, is quickly rising, and they have to leave their homes. They have to leave their islands. And it's the idea that sometime in the future, Areas of large population along the coast, they're going to face or forced to move from their homes to another location. Increase hurricane frequency. You need warm ocean waters in order to have hurricanes. If the ocean's waters temperatures continue to increase, then there's a greater opportunity for more hurricanes or greater frequency of hurricanes. And lastly, more intense storms and weather extremes.